Welcome to a slow, beginner-friendly lesson on inserting and selecting rows in a SQLite database, made for absolute beginners. The shape fills today. Today we cross an important line. Last lesson you learned to connect to a database and create a table. But an empty table is just a shape waiting for data. Today you fill it. You learn two of the most important SQL commands: insert, which adds a new row, and select, which reads rows back. By the end, you will insert real users into a real database file and read them back. We go slow, one idea at a time, with many short examples. This is where your data becomes permanent. Insert in, select out, here is where you stand. Last lesson you connected to app.db, opened a cursor, and ran create table for users. The table now exists inside the file. But a table with no rows is just a skeleton. It is columns defined, but no data inside. To make the table useful, you need to add rows. That is what insert does. And to confirm what you stored, you need to read rows back. That is what select does. Today you learned both. Two commands, one goal: real data in a real file. From shape to data, you built the columns. You named the types. But the table has no rows yet. Today the shape fills with life. The table is waiting. Here is the insert command in its simplest form. You write insert into, then the table name, users. Then a pair of parentheses with the column names you want to fill, name and email. Then the word values, then another pair of parentheses with the actual data, in the same order, Ada and Ada at example.com. The columns and the values match position by position. SQLite takes that data and adds it as a brand new row in the users table. The primary key it fills in automatically. Columns and values match. In Python, you write insert as a string passed to execute. Cur.execute, then the full SQL in quotes, insert into users, columns name and email, values Ada and her email. The cursor runs the command. One row has now been added. But remember the rule from last lesson: changes are not saved until you commit. So immediately after, call con.commit. Now the new row is truly written to disk. If you skip commit and close the connection, the row vanishes. Always commit after insert. Always commit after insert. Notice we did not include the ID column in the insert. That is on purpose. Last lesson we declared it integer primary key, which tells SQLite to autoassign IDs. The first row gets id 1. The second row gets id 2. The third gets id 3. You never insert the id yourself, SQLite handles it. You only insert the data columns you actually care about: name, email, age, whatever your table has. The primary key is your database's bookkeeping, and it works silently in the background. Trust the primary key. Insert puts rows in. Select pulls rows out. The table breathes. Data flows through your code, and disk remembers it all. Data flows in and out. There is a simple cycle to internalize. You insert a row, SQLite holds it in memory. You commit, SQLite writes it permanently to disk. You select, SQLite reads the rows back from disk into your Python code. Write, save, read. That is the heartbeat of every data-driven app. Users sign up, you insert. You save with commit. Later, someone views a page, you select. Understanding this loop unlocks everything from contact apps to web shops to dashboards. Two commands, one rhythm. Write, save, read. Now let us read rows back. Write cur.execute, then select star from users. The star means all columns. SQLite gathers every row in the table, but does not return them yet. The cursor just remembers where they are. To actually pull them into Python, call cur.fetchAll. FetchAll returns a list of all matching rows. Each row is a SQLite row object, which you set up last lesson by enabling the row factory. From here, you can loop over rows, count them, or display them however you like. Star means all. Sometimes you do not want all rows, you want just one. Use fetchown. Cur.execute, then cur.fetchown returns the first matching row. Call fetchown again, and it gives you the second row. Each call walks one step forward through the results. When there are no more rows, fetchown returns none. This is perfect when you expect at most one row, for example, looking up a single user by id. Fetchown is also memory friendly. You do not load the whole table into Python at once. One row at a time. Quick comparison. FetchAll returns the full list of rows all at once, handy when you need everything and the table is not huge. Fetchown returns one row per call, walking forward through the results, and returns none at the end. Use fetchall when you want the whole result set in a list. Use fetchown when you only need a single row, or when you want to step through results one at a time without loading them all into memory. Both are valid, pick based on what your code needs. Both are valid tools. You do not always need every column. Instead of select star, list the columns you actually want, separated by commas. Select name, email from users. SQLite returns rows that contain only those two fields. This is good practice when your table has many columns and you only need a few. Less data moves between the database and your code. With the row factory set, you access each value by its column name, row square brackets name, row square brackets email. Clean and readable. Ask only for what you need. So far, select returns every row in the table. But often you want a specific subset, users with a certain name, products under a price, orders from this week. That is the job of the where clause. You add where after the table name, followed by a condition. SQLite checks each row against the condition and returns only the ones that match. Where is how you turn a giant pile of data into exactly the slice you need. We start with simple conditions today and build from there in later lessons. Filter with where. Here is where in action. Select star from users where name equals Ada. The condition is name equals Ada, with Ada in single quotes because it is text. SQLite walks the user's table row by row. For each row, it asks, is name equal to Ada? Only matching rows come back. So if you have Ada, Grace, and Linus in the table, only the Ada row is returned. Where conditions work with text, numbers, booleans, anything you can compare. We start with the simplest case, exact text match. Text in quotes. Where also works with numbers, and notice, no quotes around the value. Select star from users where it equals 2. The number 2 has no quotes because it is an integer, not text. SQLite finds the row whose ID column equals 2 and returns it. Since it is the primary key and therefore unique, at most one row can match. This is the most common lookup pattern in real apps, fetch one row by its id. Combine where it equals with fetchOwn, and you have a precise, fast single row lookup. Numbers without quotes. You ask a question with select. The database searches its rows and answers. Data that slept on disk now speaks through your code. The data answers back. What if you want to insert many rows? You could call execute 10 times, but there is a better way, executimony. Build a list of tuples, each tuple holds one row's worth of values. Then call cur.executimony with the same SQL repeated, and pass the list. SQLite inserts every row in one efficient call. Note the question marks in the SQL, those are placeholders, filled in order from each tuple. We dig into placeholders next. After executimony, commit once. That saves all 10 rows together. Many rows, one call. You do not have to call fetchAll to read results. You can loop over the cursor directly. Cur.execute, then for row in cur:. Each step of the loop fetches one row. This is the most natural pattern when you want to do something with each row in turn, print it, save it to a file, send it somewhere. With the row factory set, you reach each field by name, row square brackets name, row square brackets email. Looping over the cursor feels like reading a file line by line, one row at a time. Walk rows naturally. Here is the complete pattern end to end. We import SQLite 3, connect to app.db, set the row factory, create a cursor. We use executimony with placeholders to insert 3 users in one call, then commit. Then we loop directly over a fresh execute call, printing the id and name of each row. Finally we close. About 15 lines. You now have real data sitting in a real database file, and you have read it back into Python. This is the smallest complete loop of write, save, read. The complete loop. One critical habit, always use placeholders, never f-strings, to build SQL with values. The question mark is a placeholder, SQLite replaces it safely with your value. The second form, with f-strings, is dangerous. If name contains a quote or a clever string, an attacker can sneak extra SQL into your command, the famous SQL injection attack. Placeholders prevent this completely, because SQLite treats the value strictly as data, never as SQL. From day one, use the question mark. Never format user data into a SQL string yourself. Placeholders always. A few common pitfalls to avoid. The biggest one, forgetting commit. Your insert runs, no error appears, but the row is gone after close. Always commit after writing. The second, building SQL with f-strings. It feels natural in Python, but it opens the door to injection. Always use placeholders. The third, selecting every column when you only need one, wasteful and unclear. The fourth, closing the connection before reading results. Cursors and rows live inside the connection. Close last, after you have everything you need. Avoid these traps. Quick self-check. Can you write an insert command with column names and values? Can you explain why commit is required after insert? Can you write a select command to read rows from a table? Can you filter rows with where, and choose between fetch_on and fetch_all? Can you loop over a cursor to process rows one at a time? If any feels shaky, rewatch the matching example. The pattern is small: insert, commit, select, fetch, but you will use it constantly. Say each line out loud as you type. Say each out loud. Here is the lesson in one breath. Insert adds a row to a table, and commit writes it permanently to disk. Select reads rows back, either all columns with star or specific columns by name. Where filters rows by a condition, so you get exactly the slice you need. Fetch_on returns a single row, fetch_all returns the full list, A for loop walks rows one at a time. And always use question mark placeholders for values, never build SQL with F strings. That is the foundation of every data-driven script. 2 commands, 1 rhythm. Next lesson, we learn to change rows that already exist with update, and to remove rows with delete. Then we deepen where with conditions like and, or, less than, greater than. We learn to count rows, sort them, and limit how many come back. But pause for a moment and notice what you can already do: store real data in a real file, read it back into Python, and search it. That is the foundation of nearly every app you use. The work continues. Update and delete come next. Thanks for learning insert and select. Next we update and delete rows. Your data is alive.